Hello students, so we are continuing questions from the topic matrices and determinants. So the next question is f of x is equals to integral of this, okay, and limit x approaches to 0, f of x equals to 0, and f of 1 is 1 by 4, and if a is this and b is adjoint of adjoint a, and such that determinant of a is 81, then alpha square equals to, I think this is a very lengthy question. Yeah, surely a lengthy question. Then what to do? Okay, and this integration looks very complicated, but I don't think it is. See, whenever we have higher powers of x in the denominator, so we can definitely think of this thing that we will take x power 9 common from the denominator. So if I take x power 9 common from the denominator, I get x power 9 whole square will be x to the power 18. And what will be remaining is 1 divided by x power 9 plus x square by x power 9 will be 1 divided by x power 7 plus 2 whole square. And then here we have 7x to the power 10 plus 9x to the power 8 dx. So this is f of x. So if I take x power 18 from the denominator to the numerator, then we get 7 divided by x power 8 plus 9 divided by x power 10 by 1 by x power 9 plus 1 by x power 7 plus 2 whole square dx. Now definitely we can think of taking this as t. So 1 by x to the power 9 plus 1 by x to the power 7 plus 2, if I take it as t, then differentiate with respect to x on both sides. I get minus 1 by x power 18 into 9 raised to 9 into x to the power 8. I hope you know how to differentiate. Yes, students, derivative of 1 by x is minus 1 by x square. Okay, here also we get minus 1 by x power 7 whole square, that should be x power 14 into derivative of x power 7, that will be 7 into x to the power 6 plus derivative of 2 is 0, that will be equals to dt by dx. So we are differentiating it with respect to x on both sides. So we can write this as minus 9 by x power 10 minus 7 by x power 8 is equals to dt by dx. Wonderful, I think that's what is the numerator. So we can take minus common. So we get 9 by x power 10 plus 7 by x power 8 times dx will be equals to dt, or plus of this will be equals to minus of dt. That means ultimately f of x becomes, numerator will be minus dt by divided by t raised to the power 2. So derivative of minus dt, so this should be derivative of 1 by t square should be t to the power minus 2 plus 1 divided by minus 2 plus 1 plus c. So ultimately we do get minus, this denominator will be minus 1, minus and minus gets cancelled. Ultimately I think we get 1 by t plus c. And what is t? T is ultimately 1 by x power 9 plus 1 by x power 7 plus 2 plus c. So if I take x power 9 to the numerator, we get x power 9 plus 1 plus x square plus 2 into x to the power 9 plus c. So this is nothing but f of x. And what did he say? Limit x approaches to 0, f of x is equals to 0. So limit x approaches to 0, f of x is 0. And if I apply limit to this part, it will be 0 by 1. So 0 plus c should be equals to 0. C will be equals to 0 because limit x approaches to 0, constant is anyways a constant. Acha, so the value of c is 0. And f of 1 is 1 by 4. Okay, let us just check whether it is 1 by 4 or not. So f of 1 will be 1 by 1 plus 1 is 2, 2 plus 2 is 4. I think it is correct only. So I think this information is given to confuse us. Fine. If a is 0, 0, 1 and 1 by 4 f dash of 1, that means we have to find f dash of x. Okay, that's how I think it is complicated. It is little challenging. So f dash of x, let me recall, u by v whole dash will be u dash into v minus u into v dash by v square. So derivative of numerator will be 9 into x to the power 8 into denominator will be 1 plus x square plus 2 x to the power 9 minus u is x power, and derivative of denominator will be 2x plus 18, 2 into 9 is 18, x power 8 divided by 1 plus x square plus 2 x power 9 whole square. Achha, we just need f dash of 1, I think, right? F dash of 1 if I'm right. Yeah. So f dash of 1, replace x with 1, we get 9 into 2 plus 1 is 4 minus 1 into 2 plus 18 will be 20 divided by 1 plus 1 is 2, 2 plus 2 is 4, 4 square will be 16. So 9 into 4 is 36, 36 minus 20 is 16, 16 divided by 16 is 1. Wonderful. So what will a be? A will be 0, 0, 1, 1 by 4, 1, 1. Alpha square 4 1. Achha, what do we want ultimately? B is adjoint of adjoint a, such the determinant of B is 81. Okay, so if I take this part B, what will determinant of B will be? That will be adjoint of adjoint a. Now take this as B, determinant. Achha, take this as C. So it will be determinant of adjoint C, and we have already learned this, dear students, in the one of the previous videos. Determinant of adjoint C will be determinant of C whole raised to the power n minus 1. What is the order of the matrix? A is 3, so that means B also should be 3 because it's a square matrix, so it should be 3 minus 1 is 2, determinant of C. And what is C basically? Adjoint A. Again, determinant of adjoint A will be determinant of A whole power 2 whole square, so determinant of A whole power 4. That means B, determinant of B will be determinant of A whole power 4. Achha, ultimately I think we have to, and determinant of B is anyways 81. So I think this, so we have to find determinant of A, right? Determinant of A we have to find. So A is 0, 0, 1. A is 0, 0, 1. Then what do we have? 1 by 4. F dash of 1, 1. F dash of 1 is, F dash of 1 is 1. Dash of 1 is 1. And then what do we have? 1, yeah, 1. Then we have alpha square 4, 1. Alpha square 4, 1. Yeah, this is A, and determinant of A will be, if I expand the determinant along the first row, what do we get? 0 minus 0 plus 1. 1 into, what do we get? 1 by 4 into 4 is 1 minus alpha square. Determinant of A is 1 minus alpha square. So determinant, 81 is determinant of A power 4, right? 81 is equal, the determinant of A whole raised to the power 4 is 81. That means determinant of A square is 9. Determinant of A should be plus or minus 3, right? And what is determinant of A? It is 1 minus alpha square is equals to plus or minus 3. That means 1 minus alpha square is either 3 or 1 minus alpha square is minus 3. Alpha square cannot be equals to minus 2 because it's real numbers. Real number square cannot be negative. So alpha square should be 1 plus 3, that is 4. He is asking us to find the value of alpha square if I am right. So alpha square will be equals to 4, dear students. That's it. Let us go to the next question. Next question says, P is equals to this and Q is equals to this. Be two square matrices of order 3, okay, such that Qij is equals to 2 raised to the power I plus j minus 1 to Pij. Determinant of Q is 2 to the power 10. Then the value of determinant of adjoint P. Okay, determinant of adjoint P. So this should be, if I take this as B, it will be determinant of B whole raised to the power n minus 1, that is 3 minus 1 is 2. So this should be determinant of P whole square. Again, determinant of adjoint P will be determinant of P whole power 2 whole square. So it should be determinant of P 2 power, A power m whole power n will be A power m into n. So it should be determinant of P whole power 4. Ultimately, we need to get a relation. Determinant of Q is 2 raised to the power 10. So we'll do one thing, we'll construct a matrix Q. So what does this mean? Q11. Q is basically Q11, Q12. Q11. Then here we write Q12, here we'll write Q13, then Q21, Q22, Q23, Q31, Q32, Q33. What is Q11, dear students? Replace I with 1 and J with 1. So here if I replace I and J with 1, we get 2 power 1 plus 1 minus 1. So it should be 2 into P11. So this should be 2 into P11. And Q12 should be 2 raised to the power 2 into P12. And this should be 2 raised to the power, it should be 1 plus 3 minus 1. Should be 2 raised to the power 3 P13. Again, so this should be Q21 should be 2 to the power 2 plus 1 minus 1. It should be 2 raised to the power 2 into P 21. I think if you have understood this, each time it will increase with the 1. So the power, you can check it yourself, dear students. If you have identified the pattern, you can directly write it. So and again, Q31 should be Q raised to the power 3 plus 1 minus 1. It should be 2 raised to the power 3 to P31. This should be 2 raised to the power 4 and this should be 2 raised to the power 5. I hope you understood this. Now what can be done? What can be done now? So so this is basically Q. What will determinant of Q be equals to? So determinant of Q will be, the matrix Q is the above one, determinant of Q will be this. So from the, dear students, from the first column we can take 2 common, and from the second column we can take 2 square common, and from the third column we can take 2 cube common. So we get 2 into 2 square into 2 power 3. What remains is, from the first column I am taking 2 common, so I will get this one. Second column I am taking 2 square common, so what will be remaining is this part. Third column I'm taking 2 cube common. Now again dear students, I think from the second row we can take 2 common, and the third row we can take 2 square common, right? So outside what remains is 2 to the power 6. From the second row we have taken 2 common, and the third row we are taking 2 square common. So what remains is P11, P12, P13, P21, P22, P23, P31, P32, P33. So ultimately we are left with 2 raised to the power 9. I think this is nothing but determinant of P, right? So what is this? This is determinant of Q. Acha, what do we have in the question? So we need to find this value. Determinant of adjoint P is determinant of P whole power 4, right? Okay, and what is determinant of Q? Determinant of Q is I think 2 raised to the power 10. So here we can write 2 raised to the power 10 is equals to 2 raised to the power 9 into determinant of P. That means determinant of P should be 2 power 1, correct? 2 to the power 10 by 2 power 9 is 2. Determinant. So what do we want, dear students? We want the value of this part, that is determinant of P whole power 4. So it should be determinant of P whole power 4 should be 2 to the power 4, which is nothing but 16, I believe. 16 should be the answer, and I think option 2 is correct. Thank you for watching this video, dear students. Meet you with the next.